So hi, today we are going to see about the Varactor diode, and this is one of the most important topic. Okay, so this Varactor diode is also called as a voltage dependent variable capacitor or varicap or voltocap or voltage variable capacitor diode. So these are all the different names of the Varactor diode. Okay, and the Varactor diode is working under a reverse bias. Okay, see, this is the symbol of the Varactor diode. And why do you all know about the PN junction diode symbol, right? So this is a normal PN junction diode symbol. So it is the positive terminal and negative terminal. So this positive terminal is also called as an anode, and the negative terminal is also called as a cathode. Okay, so this Varactor diode is, so along with the PN junction diode, you have to add a capacitor. See, this is the normal PN junction diode, and here you are adding one capacitor. So this is a variable capacitor diode, right? So that means this symbol indicates the variable, right? So this is the symbol of the Varactor diode, normal PN junction diode with a variable capacitor. Okay, so this is the construction of the Varactor diode. See, this is the positive terminal and this is the negative terminal. Here you are giving the source terminal connection. So what is the difference between the forward bias and reverse bias? So in the forward bias means the positive side of the diode is connected to the positive terminal and the NAND side of the diode is connected to the negative terminal of the battery. Okay, then it is called as a forward bias. So the reverse bias means, see, the positive side of the diode is connected to the negative terminal of the battery and the N side is connected to the positive terminal of the battery. So now this connection is a reverse bias. So this R indicates that this is a reverse connection. Okay, now if you increase the reverse voltage, then what will happen? See, this is the negative side and this is the positive side. Here you are having a P side and this is the N side. So P side contains the majority amount of holes, whereas the N side contains the majority amount of electrons, right? That you all know. So this, what will happen if you increase the reverse voltage, this negative terminal attract the holes, okay, and this positive terminal attracts the electrons. So then maximum amount of these holes and electrons will come out. Instead of crossing the junction, it will comes out. Then automatically this depletion region width will get increases. So this is the main point. Okay, so under reverse bias, this depletion region width will get increases. Okay, if the depletion region will get increase means, then this junction capacitance CT, right, this junction capacitance get decreases. See, this is the formula. C is equal to A by epsilon W. A is the area, this is the permittivity, and W is the width. Okay, so this width and this Cj, that is junction capacitance, is inversely proportional, right? So if the width of the depletion region increases, then automatically this junction capacitance get decreases. Okay, this is the concept of the Varactor diode. See, as reverse voltage increases, the depletion layer width increases, the junction capacitance get decreases. This is the main concept. So this is the diagram, symbol of the Varactor diode, and now we will see the characteristics graph. So this graph is between the diode capacitance versus reverse voltage. So what will happen if you increase the reverse voltage, depletion region increases, then if depletion region increases, this junction capacitance will decreases. See, if you increase the reverse voltage, the junction capacitance is getting decreasing. Okay, this is the concept of the Varactor diode. Okay, so this the diode capacitance is based on the reverse voltage, right? So here you are having only a three links: reverse voltage, depletion region, junction capacitance. Okay, so also this junction capacitance is, this depletion region is like a dielectric medium. Okay, see here, so the depletion region in the PN junction diode act as a dielectric medium. How? See, this is the capacitor, right? We having a two plates and the center part is a dielectric medium. So like just you compare this with the PN junction diode. PN junction diode is having a two terminal and center one is a depletion region. So the depletion region in the PN junction diode act as a dielectric medium. Okay, so under reverse bias, this reverse current saturation and remains constant. Okay, then you all know that, so at the saturation point your junction capacitance is minimum, and at avalanche point your junction capacitance is minimum. Okay, so saturation point your junction capacitance is maximum, and at avalanche point it is minimum. Okay, so if you increase the reverse voltage, the depletion region is getting increasing, so the junction capacitance is decreasing. That is the overall concept. Okay, so then what are all the applications? This is the main three applications: automatic frequency control device, frequency modulation, adjustable band pass filter. Okay.